Next, we're going to look at the one proportion Z interval in more detail, and we'll do a couple of examples. First off, the purpose of the one proportion Z interval is to estimate a population proportion P. The conditions are the conditions for the sampling distribution for P hat. 1, simple random sample. 2, population greater than or equal to 10 times the sample size. And 3, n times P hat greater than or equal to 10, and n times 1 minus P hat greater than or equal to 10. Remember, with that condition, you have to use P hat. There is no null hypothesis here. There is no presumptive value of what P should be, so you have to use P hat from your sample. Here's your formula. P hat plus or minus Z star times the square root of P hat times 1 minus P hat over n. Remember, we call that the standard error of P hat, that expression, the radical. And then on the calculator, you can find this if you go to Stat Tests A. It's way down the list. It's 1 prop Z int, and then you can find it there. So you'll have to scroll down quite a bit. Now, when you do a confidence interval, there's a procedure you should follow in every case, regardless of what kind of interval it is. And these are the basic steps of that procedure. First of all, you should define the parameter and population of interest. You're estimating a proportion P or a mean mu, and you should say P equals this, mu equals that, whatever the case might be. That also provides context for the problem, but you should define that parameter and the population that it applies to. Second, you should state and verify the necessary conditions for the interval you want to construct. These conditions will vary from one interval to another, so you have to be aware of what kind of interval you're trying to make, and then what conditions apply. Third, you're going to construct the interval. Is write the formula, show the substitutions, and then simplify. And then fourth, state your conclusion in a complete sentence in context. Here are a couple of examples of that will give you an idea about what I'm talking about. And the first example here, you want to estimate the proportion of students at your school, which has a population of 1,200 students, who are in favor of special privileges for seniors. You select an SRS of 100 students, of whom 50% are in favor, and you want to construct a 95% confidence interval. You can see from here there's a very limited amount of information that you're going to need in order to make this work. First thing you have to do is define the population and the parameter of interest. Okay, P equals the proportion of all students at your school who are in favor of special privileges for seniors. Then you're going to check the necessary conditions. We are given that we have an SRS. The population is 1,200. That's greater than 10 times the sample size. And n times P hat is equal to 57. N times 1 minus P hat is equal to 43. Those are both comfortably bigger than 10. Construct the interval. It's a 95% confidence interval for P. The formula is P hat plus or minus Z star times the square root of P hat times 1 minus P hat over n. We're going to plug in 50%, 57% or 0.57 for P hat and 0.43 for 1 minus P hat. And then since it's a 95% confidence interval, we're going to use this critical value 1.960. And that comes from the table from the previous video. When we simplify this standard error down and multiply it times the critical value, we get 0.097. And so our interval is going to be centered at 0.57. It's going to go 0.097 on either side of that. So it'll be 0.473 on the left to 0.667 on the right. And then the conclusion that we want to write, they're always going to have this kind of format. I am 95% confident that the true proportion of all students at your school who are in favor of special privileges for seniors is contained in the interval from 0.473 to 0.667. Okay, you always want to say how confident you are. You always want to say what the parameter is that you are estimating. Okay, here we're estimating the true proportion of all students at your school who are in favor of special privileges for seniors. And then say is contained in the interval from, and then give your lower bound to your upper bound. Here's another example. This is Senator Bagman again. You've heard of him. He hires you to estimate the proportion of likely voters in the state who view him favorably. You draw a random sample of 400, 240 of whom view the senator favorably. We want to construct a 90% confidence interval. Okay, well, define your parameter and population of interest. P is the proportion of likely voters in Bagman's state who view him favorably. Okay, the population is the likely voters in Bagman's state, and they were interested in the proportion of them who view him favorably. So that's the parameter and the population all defined in one brief sentence or one brief statement. Okay, the conditions are a simple random sample. Well, it's your sample. You're doing the job, so hopefully you have something that's at least random and representative of the population. The population is very likely to have more than 4,000 members. It's a state, after all, so more than 4,000 likely voters. And n times p hat and n times 1 minus p hat are both comfortably bigger than 10. The confidence interval, again, write your formula. Show your plugins. We're going to use 0.6, which is 240 out of 400 for p hat, and 1 minus p hat would be 0.4. And then after we plug everything in, we get this interval 0.5597 to 0.6403. And the conclusion is I am 90% confident that the true proportion of likely voters in Bagman's state who view him favorably is contained in the interval from 0.5597 to 0.6403.